Good day, my dear students. Today we'll continue our lectures, and for the third course students for subject Pharmaceutical Chemistry 2. And our topic is aromatic compounds, phenols, the derivatives of naphtha, quinones, tetracyclines. Except these lectures, we'll have also two lectures, and we speak about aromatic compounds during these two lectures. And first lecture about phenol group medicine substances, phenol, thymol, resarsenol, ethamzilate, the derivatives of naphtha quinones, the substances with K vitamin activity, vicasolum, oxalinum, tetracyclines, the derivatives of aureolic acid, and anthracyclines. This slide gives the full information about today's topic. Now please look at this slide. You can see that structures some phenols from the simplest phenol, oxybenzene or phenol, resarsenol, meta-deoxybenzene, catechol, ortho-deoxybenzene, pyragalol, trioxybenzene. You can see that these phenols has 1, 2, 3, 4 atomic phenols. When we speak about phenols, we'll begin from thymol. You can see that thymol 2-isopropyl 5-methylphenol, and thymol looks like the structure menthol, but in difference from menthol, thymol has double bonds in the structure. You remember that menthol, and we took menthol at our first lecture, terpenoids, and menthol has no double bonds in the structure. Thymol is received from plant Thymus vulgaris and by synthesis. Thymol in the essential oil of Thymus vulgaris, and there are 50% of phenols. Among the phenols, there are thymols. And when we speak about receiving, we must say that thymol received from para-thymol, and thymol has no hydroxyl group in the structure, in difference from thymol. When we take para-thymol with nitric acid in the medium of sulfuric acid, form nitrothymol. When we hydration nitrothymol, we receive oxyaminothymol. And when we react with sodium nitrate in hydrochloric acid, receive diazonium salt or oxyaminothymol. And when hydrolyzes in the presence of catalysator, receive deoxythymol, or exactly para-deoxythymol, and during hydration obtained thymol. The second reaction of receiving thymol from metacresol. You know that there are meta, para, orthocresol, but in this situation we receive we use metacresol. Metacresol with acetic anhydride form acetic ether of metacresol with acetone during condensation with acetone, forming isopropenyl metacresol, and during hydration form thymol. When we speak about identification, we must say that thymol, as other phenols, gives reaction with iron chloride, and this reaction with ferric chloride is specific reaction for phenols. But thymol gives reaction in the alcohol solution, and at the end of reaction form light green color. The second reaction for identification that thymol with sodium hydroxide form phenolate, sodium salt of thymol, and with chloroforming gives dichloromethane, sodium salt of thymol. With sodium hydroxide gives aldehyde compound with with sodium salt of thymol during condensation, forming aurine dye, and aurine dye has red-violet color. Then there are give the structures of compounds which form during oxidizing, for example, para-thymolquinone, 4-nitrothymol, or N-oxide of thymol in the phenol. You can see the structure, its phenol nature, it has a nitro group in 4 position to hydroxyl group, and it's in the phenol structure compound. Then when we speak about assay, we can see that bromotometric method of titration of thymol. And first of all, we add potassium bromate in the solution of thymol. In the present, potassium bromide in the acidic medium, forming dibrom thymol. And dibrom thymol, this method is called bromotometric method. It's a direct titration. When we speak about properties of thymol, we can say that thymol dissolve in the fatty oil, in the essential oil, and insoluble in water, and soluble in alcohol. And thymol is used as antiseptic, helminthicid remedy during intestinal disease, stomach intestinal, and outside for gangle, mouthwash, and also as preservative of medicine preparation. And the first preparation of phenols, and the preparation of thymol, the derivatives of thymol, or also biclothymol or hexadreps. Hexadreps has in the structure 2 molecules of dichlor or bis 6-chlorthymol, and 2 parts connect each other with methylene radical. Therefore, its chemical name 2-methylene bis 6-chlorthymol. Then when we speak about the next preparation, resarsenol, chemical name metadioxybenzene, and you can see that resarsenol received from benzene with sulfuric acid give metabenzene disulfur acid, with sodium hydroxide give disodium salt of resarsen, and disodium salt of resarsen or phenolate gives with hydrochloric acid resarsenol and sodium chloride. When we speak about identification, we can see the first reaction with ferric chloride, its specific reaction for phenols, and the end of reaction form violet color. And the second reaction resarsenol with phthalic anhydride, and at the end of reaction forming yellow-red color, but with sodium hydroxide gives green fluorescence. On this slide also gives assay method. You can see that resarsen determined by bromotometric method, and at the end of reaction from 3-brom resarsenol, and its method back titration, because the supplies of bromine were determined by potassium iodide, and the surplus of iodine is titrated by thiosulfate sodium indicator starch. Resorcinol also antiseptic remedy using during skin disease as a 2-5% water and alcohol solution and 5-20% as ointment. Resorcinol include in the liquor Castellani fucarcin as antiseptic remedy. The next preparation, phenolum puro, is the simplest among phenols, and it's oxybenzene. And you know that this preparation receiving from stone coal tar industrial method in 170 250 degrees Celsius temperature, and second method by synthesis. There are two ways by synthesis. The first one by chlorbenzene with sodium hydroxide form phenol and sodium chloride, and the second one with benzene, and during condensation with propylene form isopropyl benzene, and in present oxygen and in present catalysator forming isopropyl benzene hydroperoxide, which with sulfuric acid gives phenol and acetone. The advantages of this method that the products of this reaction as phenol and as acetone. When we speak about physical properties, we must say that this preparation, phenol, colorless crystals with specific smell appear pink color with oxygen and light. Soluble in water and other solvents. The first reaction for identification was iron with ferric chloride, iron chlor free, and its specific reaction and gives blue or violet color, and the second one forming other dye. You can see this reaction. We take some of the primary aromatic amines, for example, para-nitroaniline, or in this case, sulfonilic acid, and when we reacts with sodium nitrite in the present hydrochloric acid, form diazonium salt, and this diazonium salt with phenol, in this case phenol, in the alkali medium, form other dye. You can say other dye, and the dye had red-violet color, which we determine in the in the visible diapason of light. Also, phenol has temperature boiling 178-182 degrees Celsius, and phenol also with bromine water form dibrom phenol as precipitate, and this precipitate has white color, and the fifth one reaction is called Lieberman reaction. Phenol with nitrate sodium in present concentrated sulfuric acid form nitrosophenol, and then form quinone imine. You can see quinone, it's quinone structure compound with phenol during condensation form indophenol, and indophenol form dark green color. After add alkali, change in red color. The sixth one, oxidation and form indophenol, also forming indophenol after oxidation. First one from phenol forming quinone, and quinone with ammonia gives quinolamine, and condensation with phenol gives indophenol. And there are right, as oxidizing, we use chloramine, add several drops chloramine solution to ammonium solution of preparation and heat, form blue-green color. After add acid, change in red color. When we speak about assay usage, as also as for risarcin, bromata iodometric method, and when we speak about using, it's also antiseptic as 3-5% solution for disinfection of medicine instruments, dresses, and as preservative. The next one, the following preparation, phenolphthaleinum or purgenum, and this preparation, you can see, has the rest of phthalic anhydride and 2 molecules of phenols, and its chemical name alpha alpha D for oxyphenyl phthalate. When we speak about receiving, we take phthalic anhydride with 2 molecules of phenols from preparation and water. It's a condensation reaction. When we speak about properties, white or light yellow crystalline powder without smell and taste, slightly soluble in water, soluble in alcohol. This preparation used as laxative remedy, and also phenolphthalein used as indicator in the neutralization method, namely in the alkalimetric method, alkalimetry determination of some preparations. The next preparation, ethamzilat of ditinane, and also we can say ditinone also, and this is the structure of ethamzilat. And when we speak about properties, it's the white or almost white crystalline powder, soluble in water, freely soluble in methanol, soluble in ethanol, practically insoluble in methylene chloride. It shows polymorphism. And this preparation, ethamzilat, also gives in this slide and give the chemical name diethyl ammonium 2,5, because I have diethyl ammonium, it's salt of diethyl 2,5 deoxybenzene sulfonate, this structure. When we speak about assay, for assay method, use a serimetry method, and in titrant of this method, seriosulfate 4, and indicator oxyphenantraline. Oxyphenantraline at the end of reaction form blue color. And ethamzilat use during bleeding, and ethamzilat angioprotector, and except ethamzilat use calcidobezolat, and calcidobezolat, the chemical structure of calcidobezolat is shown here, and also use as angioprotector, except this preparation as angioprotector use parmidine, anginin, protectin, use troxivazine, venaroton, and you use hesperidine, and these preparations, hesperidine has the same properties as the quercetin and the rutazid. When we speak about ketamine and other name calypsol or ketalar, we take this preparation in this topic because this preparation has aromatic cycle, and 2-chlorophenyl has 2-chlorophenyl radical, and this preparation ketamine used for narcosis, and has anesthetic remedy, and use as during surgical during traumas and different situation, ketamine. The other preparation, chlorhexidine. Chlorhexidine also we take in this topic. Why? Because has a phenol group dichlor or D 1,6 D para dichlorphenylbiguanidine hexane, the structure and the chemical name of this preparation. Chlorhexidine has antiseptic properties, used as antiseptic for disinfection of medicinal or medical instruments, hands, tables, and for disinfection of oral and for disinfection upper respiratory tract also. The next part of our topic, non-steroidal estrogen preparations, for example, sinistrol and other preparation. The first preparation, sinistrol, and I want to remind that we took estrogen hormones. If you remember, we took at our second lecture when we speak about steroidal hormones. Among these steroidal there are estrogen hormones, for example, the estrone, estradiol, estradiol dipropionate, and if you remember, I said that this preparation belong to steroidal compounds and have in the cycle cyclopentan per hydrophenanthren. But today we learn non-steroidal estrogen preparations, and it's synthetic preparation. For example, we begin from sinistrol, other name dihydrosilbistrol, novastrol, estren, hexastrol, and this preparation has this structure, has two asymmetric carbon atoms. There are 4 isomers and DL and meso isomers. Physiological active form meso isomers, and it's shown meso isomer, D isomer, L isomer, and instead of R radical, phenol here. Then we're receiving from sinistrol received from anitol, oleum anise, and you can see the way of forming sinistrol, receiving, obtaining sinistrol. Then when we speak about properties, we must say that sinistrol white crystalline powder without smell, insoluble in water, freely soluble in alcohol, in ethyl, and slightly in chloroformium. When we speak about identification, we can see that the colored product had the following structure during oxidizing of this preparation, forming quinone structure of this preparation, and preparation with 2 molecule acetic anhydride form this structure diacetic ether of this substance, and 2 molecule of acetic acid, and temperature melting of the forming substance 137-139 degrees Celsius. The third reaction of the this preparation, forming tetrabrom derivative in acetic medium, and temperature melting of the tetrabrom derivative 232 227 degrees Celsius. When we speak about assay method, we use bromato iodometric method, and first of all we take potassium bromide, in present potassium bromide and sulfuric acid, and the surplus of bromine will determine potassium iodide, and the surplus of iodine will determine thiosulfate sodium in present starch, and its a method back titration. The second assay method, as in identification tool, to the surplus of acetic anhydride and water, and add water and form acid, then titrate 0.5 mole sodium hydroxide and indicate a phenolphthalein. You can see this reaction, acetic anhydride during hydrolysis form acetic acid with sodium hydroxide in present phenolphthalein gives sodium acetate. When we must say about that sinistrol used as salute-sinistrol oleosa 2% pro injectionibus intramuscular and on the scan, on the skin, and tabuleta sinistrol 0.1 milligram inside as estrogen remedy, and during tumor of mammary gland and prostate cancer. Then next one, diethyl silbestrol. Diethyl silbestrol had this structure and is also estrogen preparation, and the chemical name trans 3,4-Bs para oxyphenyl hexane free. The next preparation, dimistrol. Dimistrol also the dimethyl ether or diethyl silbestrol, and its colorless crystal or white crystalline powder without smell and taste, insoluble in water, alcohol, middle soluble in oleum, freely soluble in chloroform, soluble in ether, and temperature melt 122 to 124 degrees Celsius. When we speak about identification, it's given or it are given four reaction. It's given four reaction of identification with vanillin in acetic acid, then add concentrated hydrochloric acid, form yellow-green precipitate. When heat in water bath, color change in blue-green. With concentrated nitric acid form orange-red color. With silver nitrate, heat in water bath form white precipitate or silver mirror reaction call. With 1% of preparation in ethanol gives lambda maximum in 237 nanometer. When we speak about using, we must say that it's also estrogen hormone and for a long time administration during hyperfunction of ovaries as 2 milliliter 0.6% oleum solution intramuscularly. There are other non-steroidal preparations such as phosphoestrolum, sigitinum, and other preparation, octaestrolum and octafolin, and other preparation which has estrogen properties. The next part of other lecture, the preparations of quinone groups, and you can see the first preparation, oxalinum. Oxalinum has antivirus activity and used as eye drops and rhinites use, and it's used for treatment and prevention influenza, and you can see its preparation has quinone structure, for keto groups in the structure, and it's white crystalline powder, white yellowish, freely soluble in water. When we speak about identification with 30% sodium hydroxide and boiling in water bias, water layer dyes in blue color. With 1% sodium hydrosulfate and boiling dyes in yellow color, and in 5-10 minutes appears is a naphtazarine and is precipitate and has a red color. Oxalium hydration forming is a naphtazarine. You can see is a naphtazarine, which have two hydroxyl groups in the structure and double bonds here. When we speak about quantitative determination, is use ultraviolet spectrophotometric, UV spectrophotometric method, or ultraviolet in diapason in lambda maximum 290 nanometer, and using as powder and as ointment 1-3% ointment. The next preparation, which has quinone nature, is banaftone. Banaftone 6 brom 1,4 naphthaquinone. The structure naphthaquinone, two keta groups here, and quinone structure. Properties: red crystalline powder, banaftone, insoluble in water, practically insoluble in water. Also antivirus remedy, and during flu in tablets, and you can see these doses of tablets: 25 milligram and 1 decigram of as tablets, and as ointment 0.05%, 0.25%, 0.5 decibel, and 1% skin and eye disease use banaftone. And now we speak about aromatic vitamins. If you remember, we took vitamins before. Vitamin, if you remember, tetraenterpenoids A vitamins. We take D vitamins, and the third one, K vitamins. 3 of them are fat soluble vitamins. K vitamin also as A and D vitamins, fat soluble vitamins. And you can see the natural vitamins, K1 vitamins, phyloquinones, and it's shown the structure of phyloquinones. Phyloquinones has transformed and it's phyloquinones in green parts of plants, phyloquinones, and for example in leaves of cabbage, green tomatoes, and others. But there are synthetic K1 vitamins, and these phytamenadione K1 is called phytamenadione. Phytamenadione is color liquid solution, insoluble in water, slightly in alcohol, freely in hexane, chloroform, ether, and plant oils. Phytamenadione K1 trans and cis isomers, mixture of trans and cis isomers. And for identification quantity determination, we use UV method in lambda maximum 248 nanometer for assay, and phytamenadione using during bleeding, and in oil solution 10%, and in capsules 1 centigram %. And K2 vitamins, and phytamenadione, I say it the mixture of cis and trans isomers, ratio 2 to 7, You know that transizamer has biological activity, and natural A1 K1 vitamins phylloquinones is has biological activity because has transizamer. When we speak about K2 vitamins, it's menaquinones. Maybe menaquinone 4, menaquinone 6, and it's shown the structure of menaquinone 4 and menaquinone 6, and had the chemical name of these structures. And menaquinone is produced by bacteria, intestinal bacteria, and menaquinone is also menaquinone natural K2 vitamins. But in medicine practice also use synthetic analogs of K vitamins. For example, menadione, and you can see the structure menadione, 2-methyl-1,4-deoxynaphthalene, and the synthetic soluble form of menadione, which is called Vicasol, Vicasolium K soluble, or menadione sodium bisulfite. You can see this structure, and you can see that this substance has no double bond here, and has the surplus of sodium sulfite, the rest of sodium sulfite here. And the chemical name 1,2,3,4 tetrahydra 2-methyl 1,4 deoxy 2 naphthalene sulfonate sodium hydrate. But Vicasol K soluble, the chemical name 2-methyl 1,4 deoxy naphthalene, I said before. How we received Vicasol from beta methyl naphthalene with reacts with chromoxide from menadione or 2-methyl-1,4-deoxynaphthalene, and with sodium hydrosulfate gives menadione sodium bisulfite and or Vicasol, this substance. White or yellowish crystalline powder without smell, soluble in water, but slightly in ethanol alcohol, insoluble in ether. And UV spectrophotometry used for determination Vicasol into 220 to 150 nanometer diapason, and have two maximum 230 and 265 nanometer, and minimum in 248 nanometer. Then we speak about identification. Dye the flame in yellow color because of this preparation has sodium, and the second one with concentrated sulfuric acid from smell, dioxide sulfur smell, with sodium hydroxide give precipitate 2-methyl-1,4-deoxynaphthalene. It's menadione, you know the structure menadione. This precipitate has temperature melt 100 degrees Celsius. When we speak about quantitative determination, after reacts with sodium hydroxide from menadione in present zinc powder in hydrochloric acid medium, from 2-methyl-1,4-dehydroxynaphthalene, and in para position hydroxyl group. And when we determined by cerisulfate, and trisulfide 4 an indicator this orthophenolphthalein. We take as titrant 0.1 mol trisulfide, an indicator orthophenolphthalein. You can see this orthophenolphthalein, the orthophenolphthalein change color, red color to blue color, but titrate till green color because mix blue complex with yellow solution of titrant, therefore form green color. This preparation Vicasol using during bleeding and as coagulant before surgery and before different situation and when we use coagulant and is used as 1 milliliter 1% solution and orally use Pyros in 15 milligram as tablets. When we speak about tetracyclines, and in this lecture also we have titled tetracyclines, and there I give some of the antibiotics, and you know that antibiotics, the chemical substance that are produced by microorganisms and that have their capacity to inhibit and to destroy other microorganisms. And I give some of the antibiotics. For example, among them there are antibiotics which have phenol structure, for example chloramphenicol or levomycetine, because chloramphenicol belong to para-nitriphenylalkylamines. And now we speak about tetracyclines, and you must know that there are natural tetracycline and oxytetracycline, and half synthetic tetracyclines, morphocycline, metacycline, deoxycycline, and others. Now please look at the slide. You can see the structure naphthacene or tetracene. In the base of these tetracyclines lie this cycle, and you can see the general structure of tetracyclines, and you can see position 5, position 6, and because please look at this position, because a lot of tetracyclines differ each other with radicals which connect in two carbon atom in position 5 and position 6. Please look at the structure of tetracycline hydrochloridum, and you can see this structure, and you can see that one D cycle aromatic, and other cycles has or has no 1 or 2 double bonds. When we speak about tetracycline, you can see in 5 position, in difference from tetracycline, in 5 position here, oxytetracycline has hydroxyl group. On this slide you can see metacycline and doxycycline. Metacycline has this structure, doxycycline his structure. Metacycline other name, other name rhodamycin, and doxycycline other name vibramycin. Doxycycline hydrochloride and metacycline hydrochloride used in medicine, and doxycycline has in 0.5 ethanol and 0.5 water, and metacycline you can see has in C cycle, in C cycle in the position 6 methylene radical, but doxycycle has methyl radical in 6 position in carbon 6. Then we must speak about identification. You can see the structures of some substance which are formed during oxidation of tetracyclines. It's isotetracycline and anhydrotetracycline. Isotetracycline, you can see that C cycle is opened, and anhydrotetracycline, you can see that this substance has two aromatic cycle. On this slide, it's given the preparations of tetracycline, some of the preparations. Eye ointment of tetracycline, unguentum tetracycline ophthalmicum, unguentum D tetracycline ophthalmicum, unguentum tetracycline 3%, tabuleta tetracycline et nystatin abductor 1 decigram, amracin 1-3% ointment, unguentum oxazonum 3% oxytetracycline, and 1% hydrocortisone at start. You can see there are anti-microbe properties and anti-inflammatory properties in the last preparation. Then we speak about derivatives of areolic acid. These derivatives are used in medicine as anti-tumor antibiotics. For example, olivomycin. Olivomycin in medicine practice use ABCD olivomycins. And olivomycinum, this preparation, olivomycin, and you can see that olivomycin glycoside, and this glycoside has two parts of sugar, and this aglycone is olivine, and glycoside may be alivosa, aleosa, aliva mucosa, alivamosa. Different aglycone has this olivomycin, and this preparation used as anti-tumor antibiotics, and this preparation of areolic acid derivative. And on this slide, I gives anthracycline antibiotics. Anthracycline antibiotics, for example, rubamycin hydrochloride, doxorubicin hydrochloride, for example, adriamycin, adriablastin, and carminomycin also as used as anthracycline antibiotics. It's given the general structure of anthracycline antibiotics, and first of all given the structure of rubamycin, but instead of R1, R2, if we put this, for example, methoxy radical, or for example keta oxymethyl radical for doxorubicin R1, R2, doxorubicin, andriamycin or andriablastin, and R1 hydroxyl group and R2 ketamethyl group for carbinomycin, and we write the structure of these anthracycline antibiotics. These anthracycline antibiotics are also used during cancer of the uterus and mammary glands. And I think I gave the full information about today's topic, and our lecture is over. Thank you for attention. See you soon.